Right, so we have this period buffer. So this sector that needs to be very good. So I will not be talking about just because so just talking about find the latter aspect and force the unit to work. So this is the step we need to work we learn to be doing by one minus and I do learn to relate to one minus fifteen and fifty what twelve and twelve is what and fifty. Then I can make the retaining the important point B and then like I feel like C at point C. B is equal to the my vertical continuous requirement will be equal to this is equal to twelve. And I know that my horizontal equal my coefficient four coefficient of flatter express by twelve. Now if this is wrong then we that system is equal to and I go to agree B is equal to x. So then my vertical was engaged to the subscription. Gamma to be to be equal to 2 the vertical stress was 90 to now I'm working that I can find my lateral and central this being by camera. So I just think too much time with this. The rate of 26 for 9 in lateral extension equals to 38.37 millimeters per meter. Now you have to specify the lateral expression variation. You just have to monitor the variation here. So this is point C, this is point D. Now it's just like you are plotting a graph. So we are just plotting. At E it was 0, at E is 0, at D, at D is 38.076. So we just right. So this will be the variation of the expression. Along the line, if you hear me singing, then that I do really in my head. So after drawing the variation of the forces on the retaining wall, you can find the force, the force per unit weight along the retaining wall, which is given by the area of the variation. So in this case, it's 1/2 2 times the height. So the force will be equal to 1/2 times the 38.37. So that's our base times our height, which is 550 as our height 5. And so the force will be equal to what? 95.94 kilonewton per meter. Right? It's kilonewton per meter because this is in kilonewton per meter what? Well, and this is meter. So one of the meter cancel one of the meter space. Kilonewton. Then we are asked to find the force, where the force is at. You just find the center. This is a simple triangle. So you find the center of the triangle from the base, so from the two, to mostly where the resultant force is at. So let's assume this is the resultant force P0. From the base, from that force to the base. So this is X. So if this is a simple triangle, so X is going to what? The center of the triangle. So that will be 1/3 times what the length. Now, if you look at the direction, you're moving to the longer side, not the tapering side. If you are going to the tapering side, it's two-thirds of the length. But if you are going to the blunt side, the longer side, this is what I'm calling blunt. So that is one third. So XC is going to be one third of 5. And so XC is equal to what? 1.67 liters. So you can see that the force will add 1.67 liters from B or something like that. So we are done with this one. Let's move on to the next one. Beautiful, isn't it? It is. So we have this question also at rest condition, right? So this is also at rest condition. Let me indicate it here. But this time around, we have a water table. It shouldn't scare you. You just analyze it just as you usually do. So at first, what do you need? You need kilos, right? So you need your horizontal. Horizontal, you need your what? Your vertical times your kilos. So first of all, let's find kilos. Now the soil here and the soil here are the same. How did you know that they are the same? Because of what? They are they are friction force or they are sorry, yeah, how do you call it? Angle of friction of the soil, they are the same. We can see that the soil is what the same. But just that the soil beneath this place, the soil here is saturated. So yeah, we keep it back. So K naught is equal to 1 minus sine phi. Oh, probably by this time, we are catching to. So this means it is affecting the sound. So K naught is equal to 1 minus sine 32, right? I think this question I forgot to add other parameters. They gave us the OCR of the soil. The OCR of the soil, OCR of the soil is 4. So when they give you OCR, your K naught formula will change. We initially we know K naught to be this, right? Now K naught, you can also have K naught to be this. 1 minus sine phi multiplying what? The OCR to the power sine what? Phi, right? This is the this is also an expression for finding Taylor. This is also another expression based on the parameters given. So in this case, we are not going to use this. We're going to use this one. So in that case, our Taylor is going to be what? 1 minus sine 32. Hope the cutting of the tree is not causing much damage, and you can clearly hear me. And you can clearly hear me. So my K naught is going to be equal to if I put in the parameter 0.97977, right? Or so I'm going to approximate with my keynote is 0.9. Now finding my keynote, I'll come and find the various forces. So I'm labeling my retaining wall with important points. So A, B, and what? C, right? So let me start from here. So I'll see that at A, at E, V is equal to 0, so everything here will be equal to 0, will be equal to 0, right? Then at B, V is what? 5 meters, right? So my vertical is going to be gamma E. So the vertical force at B is going to be what? 17 by what? 5. And so the vertical at B is going to be 17 by 5 is what? It's 85 kilonewton per meter squared, right? Mhm. And so if I want my lateral at B, my lateral at B is simply K naught times what? VB. And so my lateral at B will be equal to, I'm very sorry with the sound. When I came here, there was no noise, but yeah, they are working, so there's nothing I can do about it. So this is going to be my lateral earth pressure at B. Then I come and take at C, right? So at C, I'll do the calculation taking the context that there is no water. Then after that, I do for water, or I do for water straight away. You get it? So let's see how we go about that one too. So, so let's see. So I see my vertical. Sorry, I see my z is equal to 5 plus 3.5, right? So my vertical stress is going to be gamma 1 z1 plus gamma effective z2. The reason gamma effective because I'm in this region, so I need the effective. So my vertical is going to be what? 17 by what? 5 plus gamma effective, that is 19 minus 10 times z2, which is what? 3.5. So my vertical, will be equal to 116.5 kilonewton per meter square. Now with that in place, I can find my lateral. But before that, so my lateral as is going to be K naught and V, right? But I can add that of the lateral earth pressure as a result of water, right? To it so that I get it, I put them together. So at C, lateral earth pressure as a result of water is simply gamma W Z, right? And so that will be equal to gamma W is 10, Z is what 3.5. And so that's going to give me 35 kilonewton per meter square. So I just put it here. So my at C is going to be K naught, which was 0.98116.5 plus my what 35. So my lateral at C is going to be what 149.17 kilonewton per meter was squared. So I just draw the variation. So let me draw the variation. Let me change the color and draw the variation. So if this was the retaining wall, give it to us. This is the retaining wall, right? At A, it was 0. At B, it was what? 83.3. Then when we went on to C, it came to what? At C, it was what? 149.17, right? So I just change them. So here was the water table, then like this. Now I can turn this side down. Oh, okay. I turn this side down. I see that here is equal 83.3. It means that from here to here, I'll subtract the 83.3 from 149. So that's going to be 65.87, right? So this is my variation. This is my variation of the forces. This is my variation of the forces. Right? My variation. Now with this, I am supposed to find the force, right? So this is the shape I have. So this, here will be my E1, here will be my E2, and here will be my E3. So the areas to give you the force. Here was 5 meters. Here was 5 meters. Here was 0.5 meters. So the force P naught is going to be A1 plus A2 plus what? A3. See this one, the shape is not a simple triangle, it's a composite shape. So we take it one after the other. So I can see that my A1, which is a triangle, which is half base times height. So A1 will be equal to 1 over 2 by base is what 83.3 and height is 5. So my A1 will be equal to 208.25 kilonewton per meter. And I go for my A2, which is a square, a rectangle. So length times breadth. So my A2 will be equal to. Now the reason why I'm not putting them together is because I also need them again when I'm finding the point of application of the four. That's why I've separated them. So it's a trick. So 3.5 by what? 83.3, and that will give you 291.55 kilonewton per meter. Then my A3, which is equal to, which is also a triangle, half base times height. So my A3 will be equal to 1 over 2 by 65.87 by what 3.5, and that will give me my A3 to be 115.27 kilonewton per meter. So putting them together, P naught is going to be putting them together, right? If I'm supposed to put them together, I'm going to get 208.25 plus 291.55 plus 115.27. And so P naught is going to be equal to 615.07 kilonewton per meter. Now the a point of application of the force. You see, with the first one that we solved, it was a simple triangle, so we could easily find a center. But this is made up of several shapes. You know, this is made up of several shapes. So we need the individual shape. Very good, right? The sum of R plus F for the resultant is equal to the individual forces times their moment arm, right? And here we are taking moment at the base of the retaining wall. So let's see. So my P naught times XC, that is the central I'm looking for, is equal to the individual forces times their central. So the individual forces. So you see that I did not put them together in this equation because I'll need them again. So the individual forces of 208.25 for the first one times is coming down. So this triangle that we have here, we are coming down. So from its centroid, coming down is what? It's 1/3 times its length, which is 5. But in this case, we have not gotten to our point that we are taking the moment. So plus the distance length, which is what 3.5. So this will only bring it here. So you need to continue, right? Then plus the other sheet, this guy here. So that is the area 219.55 times its centroid, which is a rectangle. So half times its length, that is 3.5. Then the other sheet, which is this triangle. So we're finding there, you need a force there. That's 115.25.27, 115.27 times the centroid over there. And the centroid too is 1/3 times the length, which is for 3.5. Now, if you do it very carefully, I just get 1720.6525. Now we are looking for XC. So we divide it by P naught. So XC will be equal to 1720.625, 6525. So 6525. Today, our video will have so many disturbances. Yeah, because I'm on campus every day. So P naught is 615.07. So XC is equal to XC will be equal to what? 2.797 meters from C. That's our X. So this one too, we are done. Let's see the other question. It's a very beautiful question. Is this one to address? Yes. So this one too is also address on this. So this is also address conditions to address reference condition. Yes. So first of all, we need our keynote, which will also be given by now. Here, look at the situation. The soil here, the soil here is different from the soil here because of their friction, angle of friction of the soil. So there are two different soil, right? So the K that you use for this layer will be different from the K that you use for this the K naught. So first of all, let's find all the K naught. So K naught one will be one minus sine phi one. So K naught one will be equal to one minus sine 38, right? Then K naught two will be one minus sine phi two. And so K naught two will be equal to one minus sine what? 32. So Q naught one will be equal to one minus sine 38, which is which is 0.384, and Q naught two is also um 0.47. So let's put this in place. So just as how we do it, we take our most important point to A, B, and what C, right? So at A is equal to the vertical stress. So let me start from how we used to do. Z is equal to what? 0. And so here, when Z is equal to 0, our static stress is 0, right? But here there is a surcharge at point A. So we have to consider it. So here in this case, the vertical stress at A is basically gamma Z plus what? The surcharge, right? So the vertical stress at point A, although this is going to go to zero, we are going to have our surcharge coming into play. So our vertical stress is 20 kilo newton per meter square or 20 kilopascal. In that case, our horizontal is going to be what? E not one, you get it. And so our horizontal at the, or the lateral expression is going to be 0.384 by the vertical, which is 20, right? So at E, we are going to get what? We're going to get 7.60 kilonewton per meter square. Now, the reason why at E this time around we are have the vertical and the lateral edge pressure there is because there's a surcharge at E. It's not like how we used to see it when it was there. For example, in this session, there was nothing on the surface of the and there was no structure. So in this session, there displays the structural outlets of A. Yes, at A, we are going to have some sports to do. Now let's look at B. At B also, G is what 3 meters. G is 3 meters. So the vertical stress at B is going to be gamma Z plus the the surcharge, right? So at B is going to be, you know what vertical stress is? The column of material above the plate, if there is a force, it will also push it, right? So in this case, our gamma is what? 16 times our z, which is what? 3 plus our theta, which is 20. So our vector at B will be equal to what? Our vector at B will be 58 kilonewton per meter square. And so our horizontal at B, just as K naught 1, we are still within K naught 1 region. So times what? At B. So my lateral edge at B is going to be 2 naught 0.384 by 58. So my vector at B is going to be 0.34, 384 times this is going to give me 26.112 kilonewton per meter watt square. Then we can take at C. Now pay attention. This side is a little bit tricky. So let's take at C. There is water table, right? And so I see what my Z. My Z is 3 plus what? 4. So as a result of 3 and as a result of what? 4, right? And so my vertical at C is going to be what? Gamma 1 Z1 plus gamma effective because of the water table Z what? Z2, right? Plus my Q because there's a surcharge. So my vertical at C is going to be gamma 1 was 16, Z1 is what? 3 plus the effective. You know that effective is what? The sat minus water. So the effective is going to be 20 minus here we are taking the unit weight of water to be 9 point. Is it 9.8? No, the question gave us 10. So let's stick to our 10. Otherwise, it's going to make things difficult for me to use calculator. So we have 10 by the Z, which is 4, plus our surcharge. Plus our surcharge, which is what? 20. And so my vertical at C will give me what? Give me 108. 108 kilonewton per meter watt square. So my lateral at C will be so K not P because now in this case we are working in this region, right? Uh-huh. So in that case we are working in that region. So yes, we need to P is P in fact. So K not by what? K not by 108 and K not by the vertical, right? When I finish I'll see something. Plus if there is water, I need the lateral head pressure as a result of the water. So the lateral head pressure as a result of the water is gamma WC. I the gamma W will be 10 by 2. That will give us 20, right? Ah, so I have P naught Q, which is 0.47 by the vector 108 plus this, the water is 20. So I'm going to get one before 90, 90.76 kilonewton per meter square. Now let's come here. Let's come to point B. Now at B, there is an interface of this soil and that soil, right? And so at B, there are going to be two force scenarios. One that is as a result of this layer of soil and one as a result of this layer of the soil. So what we calculated for is as a result of this layer of soil. And so we use the K not one of this soil to find it. But we are also obliged to use the K not two to find the same lateral earth pressure at that place because that is where the soil above and the soil below interfaces, you get it, and there are two different soils, you get it. And so we need, as a result of the soil above it, and as a result of the soil immediately below it. And so we need two lateral earth pressures there, you get it, because it's as a result of this guy, Q not one and Q not two. So that's what I'm going to find here. So K not two times the vertical is the same. So K not two is 0.47 by the vertical, which is 68. So this is 2 and this is 1. So in that case, my lateral head pressure 2 is going to be what? It's going to be 31.96. Now, with this in place, let's represent it in terms of the variation. So I'm coming. So, let me keep this thing from here and move it a little further. You know, allow space here and draw. So I want to draw the variation. So let me draw my retaining wall first. This is my point P, this is my point B, and this is my point C. Right? At point P, the distance length is the height is 3 here 4. Let me change the color to blue so we can see. At A this time around it wasn't 0, it was what? It was 7.68. Then at B1, that is the first B, it was so 26.112. Then at B2 it increased to 31.96, right? Then it came towards C, which was at 90.76. So this is going to be my diagram. This that we are going to have something like this. So we are can this is down. We can leave it by this. Right? So this whole thing is 26.112. Then that is from here to here, right? But from here to here is 31.96. But I want only from here to here, like from here to here, to from here to here. So I just subtract this from that, right? And that will give me 5.848, right? Now from here to here is 31.96. But from here to here is 90.76. So I just want from here to here. So I'll just subtract this from this, the 90.76. So this is 90.76. And I just make from here to here. And when I do that subtraction, it's just 90.76 minus 31.96. And it gets the other side. And so that is going to give us a 58.8. You get it? Mhm. Then also, we need from here to here, right? The reason why we are looking for those parts because these are the parts that we use to find our areas, the B's and the rest. Now, from here to here is 7.68, and from here to here is 21. So if you want from here to here, just simply 26.112 minus 7.68, right? And at that side, we are going to get what? We are going to get 18. So here is 18.432. Simple as that. So this is the variation. Now let's find, let me take this guy down a little bit down. So that me take him down a little bit down so that I can get more space to do the calculations here. So we need the force P naught, right? So P naught is simply will be the areas, right? Let me change my color so that you can clearly see where we are doing. So this will be my A1, this will be my A2, this whole thing will be my A3, this one A4, and this one E5, right? So my P naught is going to be E1 plus E2 plus E3 plus E4 plus what? E what? 5, right? So first of all I need E1. So E1 is simply a rectangle to length times breadth. So 7.68 by 3, that'll give me E1, which is what? 23.04 kilonewton per meter. My E2, which is this shape, this one, this is my E2. So that one is a triangle, right? It's a triangle. So I have base times height. So have the base is 18.432 times height, which is what? Which is 3. And that will give me what? 27.65 kilonewton per meter. Then A3 is this rectangle here. So length times breadth, right? So 26.112 by what? By 4. And that will give me what? 104 point what? 45 kilonewton per meter. Then my A4, which is also this rectangle, length times breadth, the same thing. So 4 by what? 5.848, and that will give me what? 23 point what? 39 kilonewton per meter. Then my A5 is given by um triangle to have base times height. The base is what? 58.8. The height is what? 4. And so my E5 is going to be what? 117.6 kilonewton per meter. So with that in place, I can find my P naught, right? So my P naught is simply the sum of all these areas. So 23.04 plus 27.65 plus 104.45 plus 23.39 plus 117.6. And so my P naught will be equal to 296.13 kilonewton per meter, right? And beautiful like that. Then we are supposed to find the point of application. So we use variable. So the resultant force times the momentum of the resultant force is equal to the individual forces times the momentum. So E1 x1 bar plus E2 x2 bar plus E3 x3 bar plus E4 x4 bar plus E5 x5 bar. Give this. Now, if you look at this, E1, the centroid, let me use different colors so that you can clearly see. E1, the centroid, it's a rectangle. So from here down here, that's E1, to HEQ, from here down here, because we are taking the moment always at the two. So for this, you need half of the length plus this distance. This one, so you need one third of the length to this distance. These guys are very close, so you can easily find them. You see that. Ah, so that is it. Those are the complicated one. That's why I discussed them. So P naught x bar will be equal to x continuous will be equal to a minute. So I have 23.0. So that's the first one. Multiplying and becoming multiplying 1/2 because rectangle L plus 4. So this is my moment out. The plus 4 is because we have to move down to where we're taking our moment. So the plus 4 is because of the distance from here to here. Because the centroid will take you to B, but we need to continue the distance here, C, right? Okay. So then plus 27.65, that one too. And we have one third of 3 also plus 4, then plus 104.45 as E3, which is one third and half of 4 because it's a rectangle. This one, because we are in this region, if you find half of the rectangle, if you find half of the rectangle, it will bring you directly here. You get it? That's why here you are not seeing any plus 4 because it brings you directly the point where you are taking the moment at. Then we have 23.39 multiply this is also a rectangle. Then the last one, which is let me write it here, that is 117.6 by one third of 4. That one is a triangle. So when you put them inside and you evaluate, you're going to get 665.93. But I'm looking for x, so I divide by p naught, right? And so my XC is going to be 665.93 over P naught, which is what? 296.13. So my XC is going to be what? 2.2488 meters from point what? Right? Simple as that. Alright, so there is a question here, and I will skip it. Let's go here and go and do this one. Yes, then we'll come back to that question. And this is a very typical question that actually came in and makes sense like the way for yes. So we are going to look at how it isn't the same question, but it's a simulated question. So I've made it look like, and I've added more ingredients to it, made it a little bit complicated, so that when you have an easy one, you can easily do it. And, yeah, it's yeah. I'm not saying the same question that came in the next minute. The simulated sort of question. All right, so this is the question that we have. Um, let me change something. Okay, we stick to this. We stick to this. Pi here is still 28. Yes, and it's the same story, but just that there's water table and C is here. It is left. So we'll see how to do about it. So in this case, don't see it's a soil in the surface and the axis. So this side of the retaining wall, this side of the retaining wall, in the active condition. Oh, even really in the active condition, this whole side is the active, this side is the passive. Why? Because the soil here, the bacteria will try to move the retaining wall in this direction, right? It push against the retaining wall, and the bacteria will try to push it inside the retaining wall inside the bacteria. That's the basis for the active and passive. Now you take them one after the other. So it's very simple. You take them side by side, not at the same time. So we will take the active keys for instance. Now what do you need? I need A active, right? Which is given by 1 minus times 5 over 1 plus by what? 5, right? So my active is going to 1 minus times 28, right? Over 1 plus times what? 28. Which my P is going to what? Is going to be 0.361. That's good, right? Okay. Now you know that anytime there is active formation, you are going to have depth of tension class and this kind of stuff. Although it hasn't been treated in the question, but we need it for your further calculation. Now let me label the most important points in there. So I'll call here for my active key. This is my A, this is my B, and this is my C. And before I go on, I need my depth of tension card, very important. My depth of tension card, very important. So my depth of tension crack is the point where the lateral edge pressure is equal to zero, right? So, and you know that the lateral edge pressure, the active one is given by this. I don't want to give you a formula because condition can change. When condition changes, your formula will not help you. So you just need to use this equation. So if it's given by this, so gamma GT plus, I'm sorry, active to minus, sorry. So we have KA gamma G plus, oh sorry, minus, so minus 2C square root of what KA, right? Ah, so at my depth of tension chart, this is equal to zero, and this becomes my depth of tension chart. So in that case, I'm going to get what zero equals to KA. We had it to be what 0.361. Gamma is what 17. It will be above the water table. That's why we are using a 17. Then just C minus 2 times C. C is what 15 kilopascal times square root of KA, which is a 0.361, right? So I have to move this. So I'm going to get 2 by 15 multiplying square root of 0.361, right, is equal to 0.361 multiplying 17 multiplying ZC. So over 0.361 by 17 over 0.361 by what 17. So my ZC, that's my depth of tension crack, is what 2.94 meters. So 2.94 meters is where my depth of tension. The reason why we are finding it, or the reason why is the first thing that we are finding, because it gives us a clue on what it's about. So my depth of tension crack is within this region. Do you get it? Mhm. Very important. If I find it and it's within this region, then I get to know how I do about it. Now, the reason why I did not give you a straight formula, there are cases where they will give you a set chart. When they give you a set chart, the formula that you know of will not work. That is why I said do it this way. So when there is a set chart, the formula is now going to be like this: KA multiplying the set chart plus gamma what ZC, right? Minus 2C square root of what KA. You get it? So when there is a set chart at the top, this is how the equation is going to look like. Times Z, this is supposed to be Z, this is supposed to be Z, right? And so if you want to find the depth of tension card, this becomes zero and this gives you KA Q plus KA gamma ZC minus 2C square root of KE, right? So if I want this, I'm going to get 2C square root of KE minus KA Q over KA gamma equal to Z. And this will be my depth of tension card when there is a third card at the top. You get it? But in this case, there is no third card. This one needed. So after finding my depth of tension card, I can find the stresses at the various important points. So at A, I know that Z is equal to zero, right? And because Z is equal to zero, my vertical is will be what zero, right? And so my active and pressure lateral is going to be this KA minus 2C square root of what KA. Now because this is zero, this will go to zero. And so my active is going to be minus 2C square root of what KA. Minus 2C is what 15 square root of KA 0.361. And so my active at A is going to give me what? Negative 18.025 kilonewton per meter square. That is the indication of what? The tensile strength, the tension, right? So that's the first equation. Now, assuming T was to be zero in this case, then it will be zero here, right? So you know this solution. So I'll go to at B. At B. I'm saying that the soil, you see the soil here and the soil are the same because we have the same size. At B, V is equal to 5 meters, right? And so my vertical will be gamma Z at B. My vertical gamma is what between Z is what 5. So my vertical is going to give me what? And 17 by 5 is 17. Am I forgetting it? Oh, sorry. I think I've seen the first one. Let me use my calculator. So 17 by 5, and that's 85. Oh, that's 85 kilonewton per meter square. And so my lateral is going to be my P is minus QC square root of 3 is the lateral at B. I'm still at B. Still at B. It's going to be QE, which is 0.361 by 85 minus, let me check this out, minus, yeah, minus 2 by 15, there is a 0.361. So my lateral X pressure at that point is 0.361 multiplying 85 minus 2 multiplying 15 multiplying square root of 0.361, and that is equal to 4.60 kilonewton per meter square. So that's at C, right? When we come to, sorry, at B, when we come to at C, so let me do it here. Let's see. At C, V is what? 5 plus 3. And so the vertical there is going to be gamma 1, V1 plus gamma effective. E equals effective because there's pore water or groundwater level, right? And so my vertical will be gamma 1. Gamma 1 is going to be 17 by 5 plus the effective, which is what? 18.3 minus 10. V2, V2, which is what? 3. Or so my this 17 by 5 plus 8.3 multiplied by that one is going to be 101. So I have 109.9. So at that same C, the lateral head pressure is going to be equivalent PE thing minus EC square root. Please, those who are seeing, um, you see, I'm writing it this way. It's the same as PE, gamma, and V. It's the same thing. I'm just breaking it down so that you guys can understand. So this P is 0.361 multiply 109.9 minus PC, which is 15 multiply square root of 0.361. 0.361, 0.361 multiplying 109.9 minus 2 multiplying 15 multiplying square root of 0.361. And so we are going to get lateral as P to be equal to 21.648 what? 9 kilonewton per meter. So as simple as this, right? Now we've gotten all the forces. Now the question, the PE is before tension crack and after tension crack. So you just consider it's just like they're giving you only one side. It's not anything difficult. And so with this, we can draw the variation of the force. Then we look at first before tension crack and after tension crack. So this is my retaining wall. This is A, this is my B, and this is my C. So at A we have it to be negative, so it's in this direction. So that is 18.025. At B and our depth of tension crack, we had it to be what? 2.94. So I'll see that from here to here is my 2.94. That's my depth of tension crack. So at that place, it's zero. Then at B, we had our lateral edge pressure to 12.66. 12.66. Then at C, we had it to be what? And we've not added that of water. So I need to find lateral air pressure as a result of water. That is gamma W. Okay, gamma W will be equal to N by 3. That is 30. So I just added to this. And I'm going to get it to be equal to 51.6485. So at C, we have it to be 51.648. So now I can draw my variation. So the variation starts from here, then it counts down, and it counts. Oh, what am I doing? What am I doing? So this thing like this come here, it becomes zero, then continues into the positive direction and comes here like this. And here was 18.035. I see in the next time there was no C, so here was zero, right? Here was zero in same direction. So assuming he brings the same thing and brings a C, says that exactly how it's going to look like, right? So in this side is negative. Now this is the depth of curve. So this side is positive, this side is positive. So I can take it down here. And so this is what 12.66. Then the distance from here to here will be, see that is 12.66. The distance from there to here will be. So 51.648 minus 12.66, and that's 38.988, right? So if from here to here is 2.94, and this entire stretch needs to be a 5, and that is if I just have to find the remaining, I just have to subtract and 2.94.5, and 2.94.5, and that's 2.06. So from here, the depth of tension crack to here is 2.06. Here is still my training program. So I need the forces before tension crack and after tension crack. So before tension crack is the whole thing, the whole figure that you can see here. So you need the area of this sheet. So you need the area. So this is my A1, this is my A2, this is my A3, this was my A4, right? So first of all, I need A1. A1 will be equal to a triangle. So that is 1 over 2. B is 18.025, height is 2.94, right? Then A2 is also a triangle, half B times height. B is what? 12.66, height is 2.06. Then A3 is a rectangle, the length times the that's 4.66 by 3. Then A4 is a triangle, half B times height, so half by B 58.988, height is 3. Let's see what we get. So 1 over 2 by 18.025 multiplying 2.94. So we have what? 26.496. We have 1 on 2 multiplying 12.60 multiplying 2.06. That will give us what? That will give us 13.0398, and this 12.66 by 3, that is 37.98, and this 1 on 2 multiplying 38.98 by 3, and that will give us what? That will give us 58.47. So my P, I have to add all of them together. So 26.496 plus 13.0398 plus 37.98 plus 58.47. So answer plus 26.496 plus 13.0398 plus 57.98 plus 50. I've already added the 50. So we are going to get our P naught for tensor crack is 125 point. Oh, sorry. Now this is negative. The first region is negative, right? It's negative. Because it's in the negative region. So this is that is negative. You have to indicate it. So negative 26.496 plus 13.0398 plus 37.98 plus 58.47. Right? Okay, I'm going to get 82.9938 kilonewton per liter. That's before tension crack. So after tension crack, you just consider this side to be zero, this side to be what? Zero. Then you find this side. So this is before, then after tension crack. It's simply this whole guy without the negative side, right? And so that's going to give us 13.0398 plus 37.98 plus 58.47, right? So 13.0398 plus 37.98 plus 58.47, and that will give us 109.4898. Now, if you are asked to find where the okay, so that's where they ask that. Now, the next question is for how do you call it? The passive side. So I simple as ABC. So I'm going to use this side, which will use this way so that we can look at the passive side, right? You see, it's not that. We are done with the active side. Let's come to the passive side. So the passive side is just this side, right? Okay, that one, so I will label some important part, X and Y. So as simple as this. Now, for the passive side, we need our P is given by 1 minus 1 plus sin 5 over 1 minus X sin what? 5, right? Now, the 5 given to us was 25. So the 5 was 25. So KP will be equal to um, If will be equal to 1 minus 1 plus times 25 over 1 minus times 25. Okay. So 1 plus times 25 over 1 minus times 25. And that will be 2.4639. Right? So if I have that in place, I know what formula am I using. This is the formula that we use as QP gamma V plus QC square root of QP if there is water, gamma of water times water height. Right? So this is the formula that they would actually use. So let's see at x v equals 0. So the vertical will be 0, but the lateral will be given by this. So KP, so KP which is equal to 2.4639 multiplying 0 plus PCP, P equals 20 square root of QP which is equal to 2.4639. And there is no water, so plus 0. So inside you're going to get what? 2 by 20 multiplying square root of multiplying square root of 50. That's 2.4639 4639, right? So you're going to get what? It to be 52.7873, right? Yes. Then we take another point at y, right? Y as v at y as v equals 2. So as v is equal to 2 at y, so we know that v is equal to gamma v, right? Yeah, the gamma is what in a person. Gamma is 19. So we have 19 by 2. Actually, yeah, that's continue. Very sorry about that. So we have 19 by 2. So the vertical is going to be 19 by 2. That is 38, right? 38. So if I put it inside, we are going to get this equation. I'm going to get 2p, so 2p this plus 2c square root of 2p plus gamma of 435. So this will be equal to 2p is what? 2p is 2.4639 by 38 plus 2 times 20 times square root of 2p 2.4639 2.4639. So this will be equal to 2.4639 by 28 plus 2 by 20 multiplying square root of 2.4639. Oh, 2.4639 by 38 plus 2 by 20 multiplying square root of 2.4639. Okay, we are going to get 156.415 millimeters. So we can go and draw the variation, right? So this is the retaining wall. This is the actual retaining wall. So this is A, this is B, and this is C. And at the same time, this is my X, and this is my Y. So at X, let me bring it to the same side. This is my X, X, and bring it to the other side. This is my X, and this is where my Y is. So at my X, we add a lateral X tensor be positive. So it's in this direction when we like this. So at this point, it was 52.7873, and at this point it was 156. At this point it was 156.415. And if I want the force there, it's just simple. I can even use the trapezium this one to do it. So this is a simple trapezium. You can find the force there because they do not ask you to find any where the force will act. But units still are usual. So A1, A2. So PP is going to be A1 plus A2, right? Now from here to here is 52.7873. So this item this here is going to be 156.415 minus 52.7873. That will give me 156.415 minus, yeah, 52.7873. That is 93.8277. So yeah, so A1 is a rectangle. So length times breadth, that's 52.7873 by 2. Then A2 is a triangle, so half base by 5. Base is what, 93.6277 to 72, right? So let's see what we have. So 62.7873 by 2 give us what? 125.5746 kilonewton per liter. And this one will give us 93 point what, 0.6277 kilonewton per liter. And so the force PP just add 123.125.5746 plus 93.6277. 93.6277. So our answer PP is going to be what? 219.203. And that will be kilonewton per liter. So yeah, these are the questions. Now this question, try your hands on them. Let me give you the answers to them. Let me give you the answers so that when you do it, you can compare if what you did was right or not. So the depth of tension crack, so the first one, the depth of tension crack is 3.43 meters. Determine before tension crack, the force before tension crack. So PA before tension crack was 32.481 kilonewton per meter. And after tension crack, oh sorry, Yeah, so this is before tension crack. Then after tension crack, PE equals 74.55 millimeters. So before and after tension crack, right? Mm. Then the point of application of the force, that one we have to also solve it. So these are the answers. We are going to get a triangle after development. You see, this is before tension crack, right? Then after tension crack, it's going to be like this, right? We just need the centroid of this triangle. The centroid. Remember that if the total height is 3 minus the depth of tension crack, so 3.43, so 3.43. So the remaining height left will be this. So 8 minus, let me do it fast. 8 minus 8 minus 3.43, that's 4 point, 4.57. So if you want to know where the force to act, it's going to be one third of this value. One third of this value is where it goes act when you get the answer, right? Then there's the last question here. This one to try your hands on it. Let me give you the answer so that you can compare. With your answer. So determine the rank and the depth of tension crack. In this case, the depth of tension crack is equal to 2.533 meters. Remember, there's a surcharge here. There's a surcharge here. The surcharge is 20 kilopascal. So this will be it. Then determine the Rankine active force per unit weight before tension crack. So before tension crack, you are going to get your PE is equal to 21.575 kilonewton per liter. After tension crack, you are going to get 37.98 kilonewton per liter, right? Then the point of application is just as I indicated. So we'll end here. We'll continue with foundation